I am audible and visible. Good evening, everyone. Let's start with today's class. In yesterday's class, we discussed about differentiation previous year questions, and we also solved this question here. This one, this one, this one, this one. This one was left. So this is the complete solution. Next slide is okay. So let's solve some more questions from differentiation chapter. So this was a homework question. Let's solve this. Given y is equals to f of x, and if you differentiate it dy by dx, this is p. If you differentiate it further, dy square by dx square, yani d of dx into p, that is what it is. Yes. And this is given equal to q. Okay. So this is all what is given to us. We have to find out d square x upon dy square. So first what we need to find out that dx, we are double differentiating x with respect to y. So first let's find out dx by dy. So from here we can write dx by dy 1 by p. Okay, so here d square x upon dy square will become like this. We are differentiating with respect to y. Dx by dy is 1 by p. So differentiation of anything as p here depends on y also somehow. So p is also a variable, so its differentiation is not going to be 0. So let's further differentiate 1 by p with respect to y. So p raised to power minus 1, power comes ahead, p square into dp by dy, because we are differentiating with respect to y. So dp by dy is what? So we have to find out what is dp by dy. And we know we can write dp by dy as dp by dx because we have dp by dx here. And we can write it as dy by dx because also we have dy by dx in the given statement. So dp by dx is, yes, here dp by dx is q and dy by dx is p. So this is q by p. This is dp by dy. Now let us put dp by dy's value here. So d square x upon dy square, it will become 1 by p square into q by p. Now it will equal to p minus q by p cube. So b will be our answer. Let's move on to next question. This is solution slide. So let's solve this question. So here you can see there are like bundle of questions from a single function. And now the problem with this particular function, as if we will go to directly differentiate this, then we will be entangled into a load of calculation. So before going further, same as we do with this integration, let's simplify this function, which is 1 plus x square plus x raised to power 4 plus 1 plus x square. So here we can see there is 1 plus x square already. So let us plus minus x in the numerator, which won't have any effect on the function. It will remain the same. So let's write 1 plus x square together. X4 is minus 4. X is 4 minus x together. So let's write the denominator separatively in these two terms. So our function will become 1, this will get cancelled, so it will just become 1 plus x raised to power 4 minus x upon 1 plus x square. Let's take x common from the numerator here. Taking x common, it is x cube minus 1 upon 1 plus x square. Now we know about the algebraic identity that a cube minus b cube is what? A minus b into a square plus b square plus ab. Here we have a as x and b as 1 because 1's cube is also 1. So we can write it as x cube minus y cube. So it will be equal to x minus y into x square plus x plus 1, right? So let's expand it further in the next slide. Fx is 1 plus x into x minus 1 to x square plus x plus 1, which was divided by x square plus x plus 1. So now you can see the logic here. So you cancel this and it will come out as x square minus x. Okay, so this is the function. So as per the question requirement, we have to differentiate it. So let's differentiate the function. Once differentiation with respect to x is 0, 2x minus 1. So if we compare it with this form, a is 2 and b is minus 1. Minus 1. Okay. So a is 2, b is minus 1. This is the correct answer. This solution over here. Let's come to the next question. So we have to find out the derivative of this particular function with respect to this function. So what we will do first, we will find out du, the function u, its derivative with respect to x, and v's derivative with respect to x. And then we will divide them to find out du with respect to dv. Let's do that. So du by dv, ln of x minus, so let's write it as x plus sine x, because ln x differentiation is 1 by x. Here it is x plus sine x. So multiplied by the differentiation of 1 plus derivative of this particular function's variable, which was given as 1 plus cos x, right? And then, yes, so let's differentiate the v. 1 minus sine x. Yeah, so let's simplify it and write it 1 plus cos x upon x plus sine x into 1 minus sine x. So as it is in the questions, option number A matches the answer. It was simple question. Next, our answer matches. Next question. Consider the following for the next 3 items that follow. We have this function as given. So f of x is modulus of x minus 1 whole square. So now we have to understand one thing, that this function will be breaking on x is equals to 0 or on x minus 1 is equals to 0, x is equals to 1. So these are two breaking points of this function. These are two critical points on which the sign of the function will be changing, or the modulus function sign will change. So let us consider this scenario and let us write the function for different values of x. It's minus infinity, plus infinity, 0, 1. So for any value of x which is less than 0, the function will turn as minus x and minus of minus, minus into minus, so that there is a effect of modulus function into x minus 1, right? Whole square. For any function having value between 0 and 1, it will be changing as it is as for x greater than 0, this particular modulus function will be coming out as it is positive x, and for values less than 1 and greater than 0, this modulus function will be turning negative, so minus sign will cancel minus sign as earlier. and whole square. Now for greater value of x than 1, this function is just going to remain the same. So here if we simplify this will become minus x plus x and this minus 1 whole square. Cancel this cancel this, comes out as function is 1 here. Function's value is 1 in this interval of x. For this interval of x, function's value is what should I say, x plus x, yes, and minus 1 whole square. So 2x minus 1 whole square. For this, it is simply 1. So now let us discuss the question. As we had to find out f dash of x when x is greater than 1. So for greater than 1, function is 1. So the derivative of the function here would be 0 because it is constant with respect to x. Derivative is 0. F dash x when x is belonging in this period. So this is the function. So let's derivate this. F of x is equals to 2x minus 1 whole square. Differentiating it, power will come ahead, 2x minus 1 into the derivative of this into 2. So it is 4 2x minus 1. Okay, so 4 into 2x minus 1, that is 8x minus 4. This is the correct answer. This is the correct answer. So we have these statements, we have to verify them. First, f of minus 2. Minus 2 is lying in this period, so this will be 1. Okay, f of minus 2 will be 1. F of 5, which is lying in this period, which is for x greater than 1, because 5 is greater than 1. So its value will also be 1. So yes, the first statement is true. For second statement, f double dash of minus 2. So we had earlier already find out for like minus 2 is lying in this period from minus infinity to 0. So the function is already 1. So its derivative is 0, its double derivative will be 0. Oh. So yeah, its double derivative will also be 0. For 0.5, it is lying in this period. So its derivative is 8x minus 4. Its double derivative will be 8. F double dash of 3, 1. So 1's derivative is 0 simply. So it is not equals to 4. So second statement is incorrect. Only 1 is the correct option. We have to mark here. Hmm. 84th question. Let f of x plus y is equals to f of x into f of y for all x and y. Then what is f dash of 5 equal to, where f dash of x is the derivative of the f. So here we can see by statement of the function itself, we come to understand that f is an exponential. So here we come to understand that f is an exponential function. Hmm. So what is what is the function of exponential? What is an exponential function? Typically, f of x is a raised to power x. Okay, so we can verify our statement from here that for f of x plus y, it will be ax plus y, and we can write it as further as ax into ay, which is f of x multiplied by f of y. Okay, so this is exponential function. We have verified it. So as we have f of x now, that is a raised ax. So let's derivate it. Its derivation is logarithm of a raised to the e. So we have to put x is equals to 5. So a raised to 5 log a. Now it is represented in the terms of f of 5 and f dash of 0. So let's first find what is f of 5. If this is a function, f of 5 would be a raised to power 5. What is f dash of 0? F dash of 0, f dash of 0, a raised to power 0 is 1, the logarithm of a. Yes, so a raised to power 5 is f of 5 into logarithm of a, which is f dash of 0. So this matches our option number A. So it is going to be the answer, the correct option. This was the question, previous question, which was asked in 2017 ND paper. Okay, let's solve the next question, which says this, that y is equals to cos of x raised to power cos of x to the power cos of x, and this goes on and on and on. So whenever we see something like this in power complexity is there, so we simply take logarithm on both sides. So on taking logarithm both side, log of y into log of cos x is to the power cos x and infinity. So we know the exponents come ahead or come in multiple. This is a property. So cos x raised to the cos x infinity into logarithm of cos x. Now if we understand, this is what? The same as the given function y. So logarithm of y is equals to y into logarithm of cos of x. Simple. So let's differentiate it. Okay. On differentiation, 1 by y into derivative of y, which is dy by dx. We are representing it as y dash. So this is u, this is v, u dash v, u dash v plus uv dash uh, into one derivative of cos x, which is minus of sin x. So we had to find out y dash dy by dx. So let's combine and let's write y dash's terms in the one hand side, that is left hand side. So y dash, taking y dash common, 1 by y minus logarithm cos x is equals to y into minus tan x, because sin x upon cos x is tan x. Simplifying this, 1 minus y ln cos x upon y is equals to y minus y tan x. Taking these terms to the right hand side, y multiplies y and it will become y square into tan x divided by 1 minus y ln cos x. So is our option matching with the first one? Yes. So A is the correct answer. Let's check. Yes, A is the correct answer. Let's solve this previous year question of JEE mains. This question's purpose is just to enhance our problem solving skills. Okay. So here it is a given function of some sort. I get an implicit function. And we have to find out, as per the question statement, we have to find out double derivative, we have to find out single derivative, and we have to do it on x is equals to 1. So let's first now write the function logarithm x is sine inverse of x. Let's differentiate with respect to x on both sides. So 1 by y into y dash is equals to 3 upon 1 minus x square. Your sine inverse x derivative is 1 by 1 minus x square. So y dash upon y is 3 upon 1 minus x square. Or we can write it as 3 into 1 minus x square power minus half. Because square root says that its power is half. And if it is in the denominator, if we are bringing it upwards to the numerator, then we have to write its power to the opposite sign. So let's further differentiate this on differentiating both sides with respect to x cos. So let's apply the division rule. U dash v, that is y double dash, v is this minus u v dash on v square. On the side, there's a simple single function. So power comes ahead and power gets subtracted by 1. Minus half minus 1 will go minus 3 by 2 into derivative of 1 minus x square, that is minus 2x. Once derivative is 0, minus x square's derivative is minus 2x. So 2 cancels 2, minus cancels minus. So further simplifying, RHS only 3 upon 1 minus x square. 3 by 2 power says like this is what it says, right? So this is our RHS. This is our left hand side. So now as in the question required, what we had to do, actually we had to find out, first let's find out y double dash, and then we'll multiply y double dash by 1 minus x square. Then we will on both sides we'll subtract x y dash. Okay, so this is the direction of question. Let's go. So let's simplify left hand side. Y double dash, also y 1 power upon y square, so y 1 remains, to the power 1 remains, and y dash whole square upon y whole square. So let's say square once, and this is equals to 3 to 1 minus x square root to 1 minus x square. Let's go on the next page. And yes, here we can see a pattern, y dash by y, and we have earlier find it out the value of y dash by y. So let's use it. So let's bring this to the next page. We had earlier found out the value of y dash by y. So y dash double dash by y minus, with what was that? 3 upon square root of 1 minus x square. And its square is there. Is equals to 3 upon 1 minus x square into square root of 1 minus x. So these terms are kind of similar. Let's bring it to the right hand side after squaring, solving its square's value. 3 upon 1 minus x square into square root of 1 minus x square plus 9 upon square root will cancelled by getting squared 1 minus x square. Taking on LCM, 1 minus x square into square root of 1 minus x square is the LCM. So 3 plus 9 into 1 minus x square. So yes, now as we had to find out what y dash into 1 minus x square. So let's go in this direction, send y upwards and take 1 minus x square to the left hand side's upward, to the left hand side's numerator. So y double dash into 1 minus x square. Yes, we are doing it right. Yes, we are doing it right. Yeah, into y into 3 plus 9 square root of 1 minus x square divided by square root of 1 minus x square. Now that we have left hand side somewhat, this term is somewhat relevant to the question statement. So let's now also subtract a minus of x y dash on both sides. So x y dash minus x y dash. Now what is y dash? What is y dash? Y dash is y 3y upon square root of 1 minus x square. So y dash is what? 3y upon square root of 1 minus x square. 3y upon square root of 1 minus x square. Let's add one more slide. So we have left hand side as the question statement minus xy dash. And on the right hand side will be substituting the value of y dash. Remain the same. On square root of 1 minus x square minus x y dash is was 3y on 1 minus x square. Now we have uh, all of the question statement left hand side. So, and we had to find out the question statement at x is equals to half, right? Yes, x is equals to half. So let's substitute the value of x is equals to half. Before that, we also have to substitute for y because y is also a variable on the right hand side. So let's first find out the value of y. Okay, as we have given this function logarithm e of y, logarithm e y is equals to 3 sine inverse x, right? 3 sine inverse of x. So y would be equal to e raised to power 3 sine inverse of x. Yes. For x is equals to half. Sine inverse x will be what? Sine inverse of half is what? Because on half on 30 degrees, on 30 degrees sine becomes 1 by 2. So it will be 30 degrees, but 30 degrees what? Pi by 6. It is getting multiplied by 3. So let's multiply it by 3. Becomes pi by 2. So e raised to power pi by 2 is y. We'll substitute y for e raised to power pi by 2 and x for half. Before doing that, let us see that there is this common term of 1 minus x square root. So let's find out that 1 minus x square is what? 1 by 4. So it becomes 3 by 4. So we can write it as root 3 by 2. Let's do that. Whichever our question statement is, left hand side, we are going to find the solution or answer right now. So e raised to power pi by 2 into 3 plus 9 into root 3 by 2 upon 1 plus is also root 3 by 2 minus x is what? Half 3 y is what? E raised to power pi by 2 upon square root of 1 minus x square. Which is what? Root 3 by 2. 2 goes up. So cancels 2. Root 3 cancels 3 by root 3. And let's solve it further then. So after taking LCM here, it will come 2 and it will become 6 here. Okay. So 2 cancels 2 here. And root 3 is divided by this. So we can write 6 as 3 into 2. 3 as root 3 into 2. So root 3 cancels this, root 3 cancels this. So it comes out to be 2 root 3 e raised to power pi by 2. Okay. Plus 9 e raised to power pi by 2 minus Have we done any mistake here? Minus root 3 cancelled. How did root 3 cancel? So, see the word star. Y and this. So we are complexing, we are somewhat no, making the question more complex by substituting both y and x for the same time. So let's just substitute for the value of x because we have made our calculation board very typical by writing e raised to the power by 2. And also, I suspect that I have done any mistake, some mistake. So y, let's write it as y only 3 plus 9 into root 3 by 2. Yes, root 3 by 2. 1 minus, that is root 3 by 2. Only minus, that is half 3 into y into root 3 divided by 2. Ah, yes. 2 cancels 2 here. 3 cancels root 3y. And let's solve this further. Solving this further, 2 will be the LCM. 3 into 2 plus 9 root 3 multiply. And there is the there is this denominator here where 2 will cancel 2, 3 will cancel this. So what now it will look like? It will look like somewhat this. 2y root 3 plus 9y minus root 3 into y. Okay, so this becomes 9y plus this becomes root 3 into y. Now let us look and review our calculation because I'm suspecting there's something wrong. Answer should be 9y only. Y dash into 1 minus x square minus xy dash. Y into 1 minus x square. Okay, y 3 plus 9 minus x. Y dash is what? Y dash is what? Y dash is 3y into 1 minus x square. So this is correct. And then y into 3 plus 9. Okay. Y into plus 9 minus. Hmm. 2 into root 3. Okay. So we're doing some mistake here. 3 plus 9 into that is root 3 by 2. So 2 is the LCM now. And 2 will cancel 2. It will become 6 plus okay 3. Okay. 3 solve this. Y into 2 is LCM. 6 plus 9 root 3 by 2. Root 3 into 2. This cancels this. Root 3 cancels this by root 3 into 2 plus 9. Okay, this is what we have written here. So 9y minus root 3 of y. And in the question, you're making a mistake for sure. Let us recheck all our steps. Okay. So we had a function and we took its differentiation. So 3 sine inverse of x. Okay. Okay. So y dash by y, this becomes this. Now on differentiating both sides, u dash v minus u v dash, okay, upon y square. That's okay, yeah. 3 into differentiation of 1 root 1. So it will be minus half, and 1 minus x square is 1 minus 1 minus half into minus 2x. This cancel this, and further simplifying this, it will become okay. So we have missed one x here. There's an x here. There's an x here. There's an x here. There's a x here. There's an x here. There's an x here. Simple mistake. There's an x here. Now, so if there is an x here, so x is half. It will become like this. So there will be only 3, there will be no 2. So there will be only 1, and it will cancel this. And now our question statement is 9y. Okay. Now we can substitute the value of y, which is what? 9 into e raised to power pi by 2. So this is our answer. Let's match it. A. And in the solution which I have brought, there is a different method also. You can check this out by directly just taking y and x in the simple terms. Let's proceed further and solve this question. So there's a function x cube into sine 1 by x. So like for this function, and there are options in which we have to find out the function's double derivative on x is equals to 0. But we can see the function is breaking at x is equals to 0. And whether if we see this function x cube into sine of 1 by x, so this function is not differentiable at x is equals to 0. Why? Because 1 by x is not continuous at x is equals to 0. And if it is not continuous, then how it can be differentiable? As we have earlier talked about this property, that if a function is differentiable, then it had to be continuous. It is always continuous. But if a function is not even continuous, then how it can be differentiable? Okay, so for that we can understand that these two options cannot be our answer because we cannot find double derivative of this function at 0. There are other options also, and which are finding its value on 2 by pi. So which is not 0. So let's take this function further. So f of x is x cube into sine of 1 by x. U, v. Let's differentiate it using the product rule. 3x square into sine of 1 by x plus u v dash cos of 1 by x into differentiation of 1 by x minus 1 by x square. Yes. So on f dash of x. So we have f dash of x. Let's simplify it further. X square cuts x cubed by x. And now this becomes minus sine of 1 minus x minus of x into cos of 1 minus x. Let's differentiate it further to get double derivative. So let's talk about this 3. X square, this u, this is v, u dash v plus u into v dash, that is cos 1 by x, which is of minus sign, into differentiation of 1 by x, which is 1 minus x square. Minus differentiation u dash v plus, that is because the natural sign is minus, So it will become same. U dash, sorry, U V dash is sine of 1 minus x into differentiation of 1 by x, which is what? It's getting multiplied further by 1 minus of 1 by x square. Okay. So now let's solve this question further. Minus sign cancels minus sign can sorry, minus sign cancels minus sign here also. So x cancels x power 2 by, so it becomes 1 by x now. So let's just simply put 2 by pi as in the question. So what generally terms we are having is sine 1 by x. So it will become sine pi by 2, and cos 1 by x, so it will become cos pi by 2. This simply is 0 and this is 1. So whichever term is having cos 1 by x, this whole becomes 0. This will become 0. This will not become 0. Sine of 1 by x is 1. So yes, so let's put values the next slide. Next slide have a solution. Confused. Yes. Yes. So let's continue from here because we were solving earlier here. So let's bring this whole thing the next page. And yes, let's substitute f x4 2 by pi. 3 into 2 into 2 by pi into 1 plus x, it just has become 0, plus 0, minus this has become 0, and further this x minus sine of 1 by x has also become 1. So this is 1 into minus of this is what? Minus of 1 by x. So this will become 1 by x is what? Pi by 2. This is a minus sign, so minus minus plus 3 into 4 by pi plus pi by 2, LCM 2 pi. 3, 4, 12 by 12 into 2, 24 plus pi square. Let's match our answers. Match our answer is the option which is number C is the correct option. Verify our answer. Yes, it is correct. Yes, it is correct. As per this also. Finally, note that address of 0 is not defined as it involves terms like 1 by x and x equals to 0. Okay. So this is about all the questions that are there in this chapter. There are no more slides. There are no more questions, which I have bring this class now. So now let me give you homework. I like to believe that you already have solved 5 years questions. If you haven't done yet, then please complete PYQs, make notes, and after solving these questions, make flash notes. That's it. So I guess let's conclude the class today.